Simplify. So we want to simplify fractions, fractional expressions here. So what that means is that the numerator and denominator must share a common factor, right? And because they shared a common factor, well, then we can simplify it. So let's start with this first one here. This is 5 over 10. Well, we can rewrite this as 5 over 2 times 5, right? Because 10 is 2 times 5. So in this case, they both share a factor of 5. And we want to be careful, though, because this is technically 5 times 1, right? Every number times 1 is still itself, so we can think about this as 5 times 1 and 2 times 5 times 1. And the reason we want to do that is because we see that there's a 5 in the numerator and a 5 in the denominator, which means that those 5's can cancel. Right? This only works when we're multiplying, so make sure that this is multiplying. It won't work with addition or subtraction. But 5 times 1, well, now we just have a 1, and 2 times 1, so this is equivalent to 1/2. Right? And so the reason that this works is that we could say, well, 5 over 10 is equal to 1 over 2 times 5 over 5. So there's that special form of 1 again. So 5 over 5 times 1/2, well, that would give us 2 times 5, which is 10, and 1 times 5, which is 5. So simplifying is actually a way of going backwards. So it's like we said, 1/2 times what gives us something over 10. Right? So 1/2 times 5 over 5 would give us 5 over 10. All right, let's take a look at the next example. So I'm going to take 42 over 77. And again, I want to look and say, okay, what do they possibly share? Well, 42 is 6 times 7. And I'm going to use the 6 and 7 because I see 77. That's a multiple of 7. And that actually happens to be a multiple of 11. So that's 7 and 11. And then remember, let's go ahead and put our times 1 so we don't forget that. And so if we cancel out factors, they both share a 7. So I'm left with 6 times 1 over 11 times 1, which will just be 6 over 11. All right, let's take a look at the next one here. So 88 over 90. Let's see. So 88, that's 8 and 11, but 8 nor 11 go into 90. And 90, well, 9 and 10 would work, but those don't share anything either. However, I see that they're both even. So let's try taking a 2 out first. So if I do 2 times 44, that's still my 88. And 2 times 45, that's still my 90. And again, we'll put in our 1s here so we don't forget. And the 1 there is more important for like an example like 5 over 10, where we had to have that 1 left. And because we want to remember that when we cancel, it's not just going to go away. So that 5 over 10 wouldn't become 0 over 2. No, we still had that 5 there. They just canceled. And so here we see that our 2's will cancel. And so this is going to give us 44 times 1 over 45 times 1, which is 44 over 45. And that's as simplified as we can get. All right, last example here. I see I've got 1,100 divided by 1,200. So on this one, there's a couple ways to approach it. One trick is that the zeros are going to cancel. Well, the reason the zeros cancel is because it's like both of these were multiplied by 100. So let's take that route instead. I'm going to do 11 times 100, and then times my 1, and 12 times 100, again times my 1. And so that 100 in both the numerator and denominator is why you may have seen at some point kind of a trick where you just cross out zeros. Well, and this is the official reason why. So that 100 is going to cancel. So this gives me 11 times 1 over 12 times 1. And so that just gives me 11 over 12.